multiple access. It is called as Fdma. It is a multiple access technique in which the available frequency spectrum is divided into several smaller frequency channels. Each user is assigned one dedicated frequency channel for the entire duration of communication. In simple words, we can say that many users can communicate at the same time because each user uses a different frequency. Now we can relate this with real life example. Consider a highway with many lanes. Imagine a highway with four lanes. Car 1 travels in lane 1, car 2 travels in lane 2, car 3 travels in lane 3, and car 4 travels in lane 4. All the cars can travel at the same time without colliding because each has its own lane. If you relate this example to FDMA, here highway is equivalent to total frequency spectrum, lane is equivalent to frequency channel, car is equivalent to user. Each user gets a separate frequency channel, so there is no interference. How does FDMA work? Let us see that. Suppose the total available frequency is 20 megahertz. It's divided into four channels. So, four users A, B, C, D. All the four users use 5 megahertz. User A always uses the first frequency channel. User B always uses the second frequency channel. User C always uses the third frequency channel. User D always uses the fourth frequency channel. So all users communicate simultaneously using different frequencies. Now, the total frequency band divided into divided into non-overlapping frequency subbands. Each user assigned one frequency channel. This FDMA is the basic technology in the analog mobile phone service. It assigns individual channels to individual users. Each user allocated a unique frequency band or channel. The channels are assigned on demand to users who request service. During the period of the call, the user can share the same frequency channel. It is the division of frequency band allocated for the wireless telephone communication. FDMA channel carries only one phone circuit at a time. After the assignment of a voice channel, the base station and the mobile transmit simultaneously and continuously. The bandwidths of FDMA channels are relatively narrow, 30 kHz, because each channel supports only one circuit per carrier. That is, FDMA is usually implemented in narrowband system. The complexity of FDMA mobile systems is lower when it is compared to the TDMA system. FDMA is a continuous transmission scheme, so only fewer bits are required for overhead purposes, such as synchronization and framing bits as compared to TDMA. And also here, intersymbol interference is low and no equalization is required. Let us see the disadvantages. If an FDMA channel is not in use, then it sits idle and it cannot be used by the other users to increase or share capacity. It is finally a wasted resource. And also it needs costly bandpass filters to eliminate the spurious radiation at the base station. And also the cost, cell site cost is very much high when it is compared to the TDMA system. The mobile unit uses duplexes. It is responsible for transmit and receive data simultaneously. This increases it increases the cost of FDMA. Nonlinear aspects of FDMA. In FDMA, many channels share same antenna at the base station. So the power amplifiers are the power combiners when operated at or near saturation for maximum power efficiency are non-linear. These non-linearities cause signal spreading in the frequency domain and also generate intersample intermodulation frequencies. Intermodulation frequency it is denoted as IM, which is an undesired RF radiation that can interfere with other channels in the FDMA systems. To minimize intermodulation distortion, RF filters are used. Then, how we can calculate the number of channels in a frequency spectrum? The number of channels that can be simultaneously supported in an FDMA system is given by N is equal to Bt minus 2B God divided by Bc, where Bt is nothing but total spectrum allocation or bandwidth. B God is nothing but God band allocated at the edge of the allocated spectrum. Bc channel bandwidth. So we can simply say FDMA is nothing but different frequencies for different users. Each user gets their own frequency channel. Everyone communicates at the same time. When you see the applications of FDMA, it is used in first generation mobile communication systems and also in radio broadcasting, satellite communication, and analog communication systems.